Every morning, millions of people reach for a hot coffee in a paper cup and assume they made the greener choice. It looks cleaner, it feels more natural, it even sounds responsible. But the cup in your hand may not be what it seems. If it were only paper, hot coffee would start to win that battle almost immediately. So what is actually keeping the drink inside? A hidden layer. And in many paper cups, that hidden layer is plastic. Put a clear plastic cup next to a brown paper cup with a green leaf icon, and most people will trust the paper version without thinking twice. Paper comes from trees. Plastic comes from fossil fuels. Paper feels like it should be biodegradable. Plastic feels like it should last forever. But packaging does not care about first impressions. It has to hold up to heat, moisture, and waste systems. Once a cup has to survive a steaming latte or tea, the story stops being about appearances and starts being about engineering. A disposable cup has a very specific job. It has to hold boiling hot liquid, keep its shape, and not soak through in the middle of a coffee run. Plain paper cannot do that on its own. So manufacturers add an inner barrier layer that makes the cup waterproof and heat-resistant enough to work. That layer is the reason you can carry the drink down the street. But it is also the reason the cup becomes harder to process later. The cup is not just paper with a logo on it. It is a designed package. Take a sheet of paper and pour hot coffee on it. It softens, it wrinkles, it begins to break down. Now imagine trying to carry that sheet around for 10 minutes without spilling anything. That is the basic problem paper cups have to solve every day. The cup has to stay stiff enough to hold shape and sealed enough to prevent leaks, even when the drink is very hot. So the material has to be more than paper. It has to be paper made stronger by something else. That is why paper cups are usually composites. The outer part may look like paper, but the inside is doing a second job that the eye cannot see. Think of it as a paper shell with a thin, waterproof skin bonded to it. For a few minutes, the system works beautifully. For recycling, that same design creates trouble. Once two materials are joined that tightly, separating them takes special processing. And if that processing is not available, the cup usually stops being a simple paper product and becomes mixed waste. When you actually drink from the cup, the surface touching the hot coffee or tea is often not plain paper at all. It may be polyethylene, or PE. Some cups use PLA, a plant-based plastic. Others use newer barrier layers that are water-based or mineral-based. The exact material can vary, but the key point stays the same. The drink is touching a coating. That small detail changes the environmental story. A cup that looks paper-like on the outside may behave very differently once it meets heat, moisture, and disposal. Recycling paper depends on breaking the fibers back apart. A plastic film inside the cup resists that step. So a cup that seems easy to recycle on a shelf can become difficult the moment it reaches a real sorting line. Facilities may need special equipment, and without it, the cup often ends up treated as waste. That is why the cup's visible material can be misleading. The outside suggests one thing. The inside tells a different story. And that difference matters the moment the cup leaves your hand. So the first contradiction is already clear. A paper cup can look like the greener choice, but the thing that makes it useful is often the thing that makes it harder to handle later. By the time the drink is finished, the cup is no longer just paper in the environmental sense. It is a mixed material product with a short life and a complicated afterlife. That is where the simple story starts to break down. Now add heat. Heat can soften materials. It can increase chemical movement, and it can make tiny particles detach more easily from surfaces. That does not mean every warm drink is identical, or that every cup behaves the same way. It means temperature is not a side detail. It is part of the experiment. Once hot liquid meets a lined cup, the material is being pushed in a way that cold storage never would. And that is exactly why researchers keep looking at what happens next. In one study, researchers filled paper cups with hot water and tested what came out. They reported an average of about 25,000 microplastic particles in a 100 milliliter cup after 15 minutes. That number does not describe every cup everywhere, and it should not be treated like a universal label. But it did make the issue hard to ignore. The cup was not just holding hot water. Under those conditions, it was releasing tiny plastic particles into it. For a product many people think of as paper, that is a very different picture. That result still needs careful reading. It depends on the cup design, the temperature, and how long the liquid stays inside. So this is not a verdict on every paper cup in every cafe. It is evidence that materials and heat matter together. The cup is a system, not a slogan. And once you start thinking that way, the question changes. It is no longer, is this cup made of paper? It becomes, what happens when this material meets a hot drink? More research on takeaway beverage containers points in the same direction. In those tests, fully plastic polyethylene cups released more microplastics than PE-coated paper cups, but the coated paper cups still released some particles. So the comparison is not simple. One material can outperform another in one test and still have its own problem in another. The broader lesson is not that paper is secretly plastic, or that plastic is always worse in every case. The broader lesson is that heat changes what these containers do. That is why the honest answer is nuanced. Paper cups may be better than some plastic cups in some situations, but they are not automatically clean, green, or plastic-free. The material on the outside is only part of the story. The lining, the temperature, the time, and the waste system all matter too. When a label makes a disposable product sound simple, the real world usually adds complications. And those complications are the difference between a cup that looks responsible and one that actually is. At this point, it helps to separate two words that get used a lot: microplastics and nanoplastics. Microplastics are plastic particles smaller than 5 millimeters. Nanoplastics are even smaller, and they are much harder to measure. That size difference matters because tiny particles can behave differently, and because our ability to track them gets more difficult as they get smaller. So when people talk about particles from cups, they are often talking about a range of sizes, not one single thing. The science gets more complicated the smaller the pieces become. What do we actually know from the bigger picture? We know people are exposed to tiny plastic particles in everyday life. We also know the exact long-term effects are still being studied. That is why this topic should be taken seriously without jumping ahead of the evidence. The story is not finished. And when the science is still developing, the best response is usually to reduce avoidable exposure where you can, while still staying honest about what is known and what is not. That leaves two bad reactions to avoid. One is panic, treating every paper cup like an emergency. The other is dismissal, deciding the particles are too small to matter. Both reactions are too simple. The evidence does not support fear as a substitute for understanding, and it also does not support ignoring the problem because it is inconvenient. A better response is precaution. Keep the scale in mind, keep the uncertainty in mind, and keep the everyday habit in mind, because habits matter when they happen again and again. Now shift from health to the environment. To judge a cup's impact, you have to follow its full life cycle. The raw materials, the manufacturing, the transport, the use, and the disposal. That means the word paper is not enough by itself. A paper cup can still require energy, coating, printing, and shipping before anyone ever drinks from it. The visible material is only the first chapter. The rest happens long after the cafe counter. After disposal, the cup has to go somewhere. In a landfill, the paper part may break down without oxygen, which creates another problem. If it is burned, the whole system becomes an air and carbon issue. And if it is littered, it becomes a problem for waterways and wildlife. 3 paths, 3 different outcomes, and none of them is clean. That is why the afterlife of a cup matters just as much as the moment you finish the drink. This is where the bigger environmental trap appears. A cup that lasts 15 minutes still consumed trees, water, energy, printing, coating, transport, and waste handling. That is a lot of infrastructure for a very short life. So the main comparison is not really paper versus plastic. It is disposable versus reusable. Once you see the whole system, the question is no longer which single-use cup looks better. The question is why the cup has to be single-use at all. Now add the word compostable, and the picture gets even more confusing. Some cups use PLA, a plastic made from plant sources. That sounds reassuring, but the label can hide a lot of conditions. Words like biodegradable, plant-based, and compostable can sound like a finish line when they are really just a starting point for more questions. A cup can be technically described one way and still not fit the waste system around it. So the label alone does not tell the whole story. That leads to the crucial question: compostable where? In an industrial facility? Maybe. In a backyard pile? Maybe not. In normal paper recycling? Often no. The answer depends on the system around the cup, not just the promise printed on the side. A claim that sounds simple in advertising can become complicated the moment it meets real collection and processing. So with compostable cups, as with recyclable cups, the material name is only part of the truth. So how do reusable options compare? A reusable cup changes the math because it is used again and again. In a cafe, ceramic, glass, or stainless steel usually wins against another disposable cup. It may not be as convenient in the moment, but the environmental burden gets spread over many uses instead of one. That is why the greenest cup is not the one that looks the most natural. It is the one that does not need to be remade for every drink. So the real story is not that paper cups are good or bad. It is that many of them are disguised composites, a paper shell doing the visible work and a hidden layer doing the practical work. Their environmental value depends on the system around them. The cleanest upgrade is usually fewer disposable cups. What do you use most often? Paper cup, plastic cup, or reusable mug? Comment below. And next time, check the cup before you trust the leaf icon.